Alright people, we will start with ray optics. Okay, so we will continue with ray optics. What we are going to do is today we are going to cover certain concepts as well as problems. Okay, so I'll try to finish as many problems as possible. Again, as I said, a very descriptive chapter. It will take a lot of time to cover almost all the aspects that are related to various competitive examinations, and obviously a lot of time has to be spent in this chapter. I feel that with the reduction in the portion for 12th standard CBSE, students have an advantage to prepare more for concepts which are correlated both to IIT as well as their boards. So a lot of load has been taken away from you in terms of boards. So now you cannot frame an excuse that for preparing for boards I lost an opportunity to actually prepare for the various competitive examinations. To keep an eye on all these concepts, not only from my end but from wherever you can get inputs. Please do keep an eye, crack as many problems as you can, because this is the best time to utilize with the reduction in the syllabus that has happened evidently, not due to pandemic reasons but whatever the reasons are. Okay, so this actually gives you a benefit to focus more on the core chapters of competitive examinations and their concepts as well. Okay, all right, so we will start with a concept in reflection of light. Okay, wherein we have basically two plane mirrors. We have two plane mirrors which are inclined at an angle theta, at any angle, let's say at an angle theta. Okay, so what we have to find out is the deviation produced in the incident ray, Now what we need to realize is deviation is a concept which is by far and large associated with prisms. Okay, but here we are talking about simple plane mirrors where there is a deviation produced. These mirrors are inclined at a certain angle and there is a certain amount of deviation that is produced. So let's look at this. Okay, let's basically look at this. So we have, let's say we have a mirror like this and this is basically inclined to another mirror. This is pure geometry. So let's say this is inclined to another mirror. Okay, let's draw the polished surface of the mirror. So this is basically happening to be the polished surface of the mirror. Okay, so now what we have is basically a ray of light. So let's say this ray of light is coming from any direction or from any object. Okay, it is incident on this mirror. So how will we draw the reflection? Obviously by drawing a normal here. So obviously what will happen is that this will be the reflected ray. This will be the reflected ray striking the other mirror at this point. Okay, so now we have let's say so let's draw a normal at this point. If I draw a normal at this point, what I will have here is a reflected ray which is going somewhere in this direction. Okay, so if I happen to extend the incident ray a little more backwards, okay, all right, so here we have the angle as sigma. Let's say this angle is alpha and this angle is alpha. Okay, so here we have the incident ray, here we have the reflected ray. Again this gets reflected here. Okay, this gets reflected here. So obviously what will be this value? See, this is what will be, see, the deviation produced. This is basically the ray and this is where the deviation is produced. So if I happen to extend this, incident ray, let's say a little backwards, okay, then what will be the deviation produced? this is going to be the deviation. So let's name this as delta 1. Let's name this as delta 1. Okay, here the incident ray comes like this and it gets reflected like this. It comes like this and it gets reflected like this. So what is the deviation produced in this case? This will be, let's say, delta 2. Let's say this is deviation produced as delta 2. This is deviation produced as delta 1, and since it is getting, this is basically the ray coming in like this, and okay, let's say I extend this here, okay. So if I happen to calculate the entire deviation, this will be the entire deviation, there is delta 2. Okay, so delta 1 here and delta 2 here. Obviously what will be the, see, delta 1 is produced here, so this entire portion is going to be the net deviation, and it's very obvious this net deviation which has been produced will be the sum of deviations of delta 1 and delta 2. Okay, so what we can write here is that the net deviation that is produced will be the sum of deviation 1 and deviation 2, delta 1 and delta 2. Okay, so let's say now we have here the net deviation. Okay, so basically this is 90, so how much will this angle be? So delta 1 will be how much? Delta 1 will be how much? This is 90, this is sigma, so this is 90 minus sigma, 90 minus sigma, and delta 2 will be how much? Delta 2 will be how much? Delta 2 will be equal to, this is 90 minus alpha, this is 90 minus alpha, sigma delta 2. Oh, I am making this wrong here. See, delta 1 will be 180. I am so sorry. So here delta 1 will be equal to 180 degrees minus sigma plus sigma, that is 2 sigma, and delta 2 will be 180 degrees minus 2 alpha. So if I happen to add delta 1 plus delta 2, this is going to be 360 degrees, right? Delta 1 360 minus 2 alpha plus sigma. I have just taken out 2 as common. Okay, so let's say this is delta 1 plus delta 2. This is delta 1 plus delta 2. Okay, now let's come to this part, that is delta net. Okay, how will we calculate this? So now let's look at this triangle. So if I happen to name this for convenience as triangle ABC, in triangle ABC, angle A will be equal to what? See, this is basically 90 and this angle is sigma. Look at this very carefully. This is 90, the normal, this angle is sigma, so this angle is going to be 90 minus sigma. So this will be 90 minus sigma. Okay, and similarly, what will be the value of angle C? Angle C here will be 90 minus alpha, 90 minus alpha. So if I happen to add these two, and what is angle B? Obviously, let's say two plane mirrors are inclined at an angle theta, so this will be theta. Okay, so angle B is basically equal to theta. So if we add angle A plus C plus angle B, this will be obviously 180 degrees. So this will be 90 minus sigma plus 90 minus alpha plus theta is equal to 180 degrees. Okay, this gets cancelled. So what we have here is minus sigma minus alpha plus theta is equal to 0, plus theta is equal to 0, or we can say theta is equal to alpha plus sigma. Theta is equal to alpha plus sigma. So delta 1 plus delta 2 is equal to 360 minus 2 alpha plus sigma. Alpha plus sigma will be 2 theta. Delta 1 plus delta 2, 360 minus 2 theta. So this will be 360 minus 2 theta. Delta 1 plus delta 2 will be 360 minus 2 theta. Delta 1 plus delta 2 will be equal to 360 minus 2 theta. Are we clear on this one, people? Okay, this is basically deviation. This is deviation of, very important to note this, deviation of incident ray in anti-clockwise direction anti-clockwise direction. If we were to calculate the deviation in clockwise direction, deviation of incident ray in clockwise direction, deviation that will be equal to theta, that will be equal to basically 2 theta, sorry 2 theta. Okay, so deviation in anti-clockwise direction will be 360 minus 2 theta, or we can also write delta 1 or delta net is equal to 2 pi minus 2 theta, that is anti-clockwise direction, and 2 theta in clockwise direction. Okay, so this is how the basically deviation of incident ray happens. Okay, deviation of incident ray happens. Okay. Okay, so just considering another example of inclined mirrors. Okay, so let's consider this example here. I have a mirror which is, let's say, like this, and it is basically inclined to another mirror. It is inclined to another mirror at an angle of, let's say, 30 degrees. So if I happen to draw the polished surface of this mirror, obviously this is the polished surface of this mirror, and let's say if I draw a normal here, and let's say there is a ray of light which is incident so there is basically a ray of light which is incident at an angle of 50 degree. So there is basically a ray of light which is incident at an angle of 50 degree. If the ray of light is incident at an angle of 50 degree, obviously it will get reflected at an angle of 50 degree as well. Okay, so here what you have to find out is the total deviation, of the incident ray, the total deviation of the incident ray. Okay, so here it is 50, so obviously this one will be how much? 50. Okay, if I were to calculate, so this is basically, see, the total deviation, there will be 3 reflecting surface, 1, 2 and then finally 3. Okay, so if I happen to calculate delta 1, okay, so oh my god, what did this happen? Okay, got it. Okay, so 50 and this is 50. So if I happen to extend this ray, let's say if I happen to extend this ray, then this obviously will be delta 1. This obviously will be delta 1. If this is delta 1, so what will be the value of delta 1? Obviously 180 minus 250 plus 50, 2 into 50 plus 50. So that will be how much? 180 degrees minus 2 into 100, that is 250 plus 50, sorry 50 plus 50, 2 into 50, it will be 2 into 50, I am so sorry. This will be 2 into 50, that is 2 into 100 degrees, that will be 80 degrees. So this will be delta 1. Now look at this. This was the ray, actual initial ray, and it has deviated by an angle delta 1, and this angle happens to be 80 degrees. So this is the deviation which has happened. Okay, so that is delta 1 is equal to 80 degrees. Okay, now let's come to this one. Let's come to this surface. Okay, so here we have the normal here. Okay, and what happens is, again a sort of reflection happens here. So if this reflection happens here, let's say this reflection happens and the ray falls here. Okay, shall I make this a little larger for a better view here? Okay, let's make this a little larger here. Maybe a pixels are going here and there. Okay, so here we have the angle. Okay, now let me know what will this angle be. So obviously consider this triangle here. This is 30, this is 50, this is 90. So how much would this angle be? This angle right here, it will be obviously 40. Very much understood. Normal minus 50, so this will be 40 degrees. This is 30 degrees. So obviously what will this angle be? this entire angle is going to be 110 degrees. This entire angle is going to be 110 degrees. Now out of this 110, this is 90, this is 90. So what will this angle be? This angle is going to be 20 degrees. Okay, so this angle is, this is 90, this is 110, 110 minus 90, this will be 20, this will also be 20. So if I were to calculate the deviation, see, look at this deviation here. The ray was coming in this direction, the incident ray that was there was actually coming in this direction. Look at this very carefully. At this surface it was coming in this direction, okay, and it, sorry, I am so sorry, don't get angry, okay. Alright, so the incident ray, this incident ray has basically, this was sort of coming here, now it has got deviated by this distance. So this is the deviation that is produced. Look at this very carefully. Understand this, this delta 1 is in which direction? Understand the direction here. This is anti-clockwise. This is basically anti-clockwise direction. This is anti-clockwise direction. This is, let's say, delta 2. Now delta 2 will be equal to 180 minus 2 into 20 degrees. That will be 180 minus 40 degrees. That will be 140 degrees. So delta 2 is going to be 140 degrees. But it is in which direction? See, here to here. This is the actual ray and it got deviated here. So this is basically clockwise. This is clockwise. Clockwise. Okay. Now let's come to this one. Let's come to this one here. Okay. So we know that this now here. Let's say if I draw a normal here. If I happen to draw a normal on this surface, okay, so this is the ray which will get reflected. This is the ray which will get reflected here from here. Okay, so too many jumbled up things are here. If I kind of rub this out, too much of khichdi has happened here. So we will just take this as delta 1. The value has already been calculated. This is 30. Okay, this is, sorry, delta 2. This is delta 2. Okay, now let's look at this. Okay, we have here 40 degrees. We have here 30 degrees. What will be the value of this angle? What will be the value of this angle? See, this is 90. We just calculated the value of this angle to be 20. If this is 20, obviously this will be 70. If this is 30, this is 70, then obviously this angle will be how much? 70, 30, 100. So this angle will be 80 in this triangle. If this is 80, obviously this angle here will be 10. So angle of incidence and angle of reflection both will be 10. So if I were to calculate the deviation, so now let's look at the deviation here. It might seem a little confused here. Okay, so if I happen to calculate this, this will be 10. If this is 10, then let's say if I draw a ray of light here, if I draw a ray of light like this, this is basically the extended ray of light that was going in this direction, but it got deviated by this. So this will be our delta 3. This will be our delta 3. What will be the value of delta 3? So obviously delta 3 will be equal to 180, this 180 minus this 180 minus 2 into 10. 2 into 10, 10 degree for angle of incidence and 10 degree for angle of reflection. So this will be 180 degrees minus 20 degrees, that will be 160 degrees. So delta 3 will be 160 degrees. But in what direction? Look at this very carefully. This is the incident ray, this is the reflected ray. So what is this is basically what? Clockwise direction. Very important, people, very important. Which direction is it moving on? Clockwise direction. Okay, I need to shorten this up, otherwise it's going out of the board. Okay, so this will be basically clockwise direction. It's too much short, it seems. Okay, clockwise direction. Okay, so now the total deviation produced, total deviation produced will be equal to delta 1 plus delta 2 plus delta 3. Delta 1 plus delta 2 plus delta 3. So delta 1 is 80 degrees clockwise, 80 degrees clockwise. Delta 2, sorry, anti-clockwise. This is anti-clockwise, 80 degrees anti-clockwise. Delta 2 is 140 degrees clockwise. Okay, clockwise. So this will be 140 clockwise, and delta 3, as we see, is 160 degrees clockwise. So obviously the total deviation will be this minus this. So this will be 140 plus 60, that's going to be 200 minus 140 plus 60, that will be 300, sorry, 300 minus 80. So this will be 220 clockwise, or we can say 360 minus 220, that is 140 degrees anti-clockwise. This will be the deviation produced. So we basically have to consider all the factors. How is the incident ray coming in, and from which surfaces is it getting reflected, in order to calculate the exact deviation produced. Okay, we'll consider more examples for this. Alright people, so we will consider cases in which two mirrors are more or less perpendicular to each other. The two mirrors are perpendicular to each other, and how we will find out the coordinates of the images that are formed. Coordinates, okay. So let's say we have let's say we have a mirror which is placed like this, and let's say there is another mirror which is placed like this. If I happen to basically draw, this is the reflecting surface, this is the reflecting surface of one mirror, and let's say this is the reflecting surface of the other mirror. Okay, so let's say we have a point object somewhere here. Okay, now how will, and let's say the coordinates of this point object is x and y. The coordinates of this point object is x and y. So what we will have here is, let's say one incident ray which is, let's say, at any angle, and it is falling here, and let's say there is another incident ray which is so let's say there is another incident ray, let's say, falling at any angle. Okay, so what will happen is, obviously, if I draw a normal here, if I happen to draw a normal here, and if I happen to draw another normal here, if I happen to draw another normal here, so after reflection they will be going like this. Okay, this will be going like this with angles. Okay, this will be going somewhere like this, and obviously after reflection this will be going somewhere like this. So it will be going somewhere like this. Okay, so they would be actually dispersing off. So let me be a little precise here. So it's going something like this. Okay, something like this. Okay, now if I extend this, it will meet up somewhere here, and this is going and this is going to come somewhere here. So these are where they will be meeting. By geometry we can say that this point, let's say that we name this as the first image. So the I1 portion will be formed here, and obviously what will be the coordinates of I? So this is basically x. We have just, the altitude remains the same, the point remains the same. So the y coordinate is along the y axis, which is going to remain the same, but the x coordinate has come along the minus x axis. So we have taken this reference point as 0, 0. so this will be minus x and y, minus x and y. Okay, in the same way, if I have rays, let's say I take two rays out here. Let's say one is falling at this angle, and let's say the other one falling somewhere here, If I happen to draw normals here, let's say if I happen to draw a if I happen to draw a normal here, so let's say I've drawn a normal here, and why did I delete it? So if I draw a normal here like this, and let's say I draw a normal here like this. Okay, so what will happen is, after reflection, this will move on like this, and after reflection, since this angle is greater, this will move on somewhere like this. If I happen to extend this beyond, these rays are going to meet up somewhere here. Okay, obviously this angle, or rather the coordinates of this point will be, this is x, so x coordinate will remain the same, so hence it will be x and minus y. Okay, now the point is that you will have another, so these are basically the reflected rays. If I happen to draw another ray out here which is falling after reflection as here, okay, so let's say if I take, just one moment here, my pen is little dicey here, 1 second here. Okay, so if I happen to draw another ray like this, maybe too many rays will confuse you, but okay, so let's just choose this ray here. This is falling like this, and let's say we have another ray which is falling like this. So so if I happen to draw normals here, so let's say this is the normal here, and let's say this is the normal here, so after reflection what will happen is, they will fall somewhere here, and this is going to fall somewhere here, Now if I happen to draw normals here, if I happen to draw normals here, should I select another color here, because it's getting a little confusing here. So I will draw the reflected rays here. Okay, so let's draw the reflected ray here. This will be somewhere here, and obviously the reflected ray from here will reach, this one reflected ray, and the reflected ray from here will reach somewhere here. Okay, this is obviously the virtual rays. Okay, so these are going to form the third image. The third image of the object will be located at a point I3. Okay, so here you have I2, here you have I3. So by geometry, what will be the position of I3? Again, look at this. This will be minus x, and the same distance above, that is y. Okay, the same distance below, so this will be minus y. So in case of two mirrors, in case of two mirrors at an angle of 90 degree with each other. In case of two mirrors at an angle of 90 degree with each other, and if the object has coordinates x, y, then there are three images, I1 which is basically having a coordinate of minus x and y, then there is I2 which is having a coordinate of x and minus y, and then there is I3 which is having a coordinate of minus x and minus y. So these will be the three coordinates of the three images that will be formed in the mirror. I hope this is clear. See, there is a formula and we will talk about the formula as well, but before we talk about the formula, we need to have a clear idea as to how images will be formed in two mirrors which are inclined. Okay, so in this one I am going to just share with you some tips on calculating the number of images. So here I am going to just share some tips on calculating of number of images, formed by two plane mirrors inclined at a certain angle. Formed by two mirrors inclined at a certain angle. Okay, very important tips, shortcuts these are. Okay, so first one is, if the two mirrors are inclined at an angle theta, okay, so and if 360 by theta is equal to an even number, then the number of images that we will have, the number of images is going to be 360 by theta minus 1. So understand this, if this happens to be an even number, then the number of images will be 360 by theta minus 1. Again, if 360 by theta is equal to an odd number, if 360 by theta is equal to an odd number, then the number of images will be equal to 360 by theta minus 1. But there is a condition to this. What would be the condition to this? The condition to what color do I choose? The condition here is that the object lies on the angular bisector of the two mirrors. So the object basically lies on the angular bisector of the two mirrors. Angular bisector means that, let's say these are two mirrors and the object lies somewhere here between the angular bisector, then it will be 360 by theta minus 1 if this happens to be an odd number. Now the second case will be what? The condition, the object doesn't lie on the angular bisector of the two mirrors. If the object doesn't lie on the angular bisector of the two mirrors, what will this be? This will be 360 by theta, and if this happens to be an odd number, 360 by theta, if this happens to be an odd number, so the number of images will be equal to 360 by theta. I suppose, yes, 360 by theta. and if 360 by theta, so this will be applicable to if the object doesn't lie on the angular bisector. 360 by theta, if this is not an integer, then we cannot apply this formula. This formula is not applicable this formula is not applicable. We have to find out number of images by manual drawing, and hence the concept of drawing is important. Okay, we have to find out the number of images by manual drawing. This is how the applicability is for the mirrors which are inclined at a particular angle with each other.